Hello Math 2 students, this is Miss Brown. I'm going to do a video of me explaining some things today. So what we are doing is practice 4-2 and 4-3, and this is what your worksheet should look like. I will take a picture of that and upload it to YouTube in just a few moments. If you have your packet, you should already have this. But we are proving that triangles are congruent. Now, what we're going to do is prove by one of four different methods. We have the side-side-side method, which we're going to abbreviate SSS. That just means all three sides of the two triangles are congruent. We also have side-angle-side, SAS. We have angle-side-angle, and we have angle-angle-side. Now, these are the only four methods that you can choose from, and I'm going to walk through and show you what each of these look like. Okay? The great thing about having a video is that you can always pause and go back and make notes for yourself. So I encourage you to do that if you need to. The first method of proving that two triangles are congruent is the side-side-side method. I want you to notice the markings on here. I have that this marking is the exact same and identical to this marking. That implies that these two sides are the exact same length. This side has the same type of marking as that one, and the bottom of the triangle has the same marking as the bottom of this triangle. If we go back to what we did in Unit 1 with our transformations, these two triangles look like a translation has taken place. So this triangle is identical and congruent to this triangle using the side-side-side method because all three sides are the same. Now, if you will notice this triangle that I have here, I've got two separate triangles, and it looks like they've been reflected over this vertical segment here. So this left side is congruent to that right side. This bottom is congruent to this bottom, but I'm going to actually add in this third segment right here. You can see that this segment from top to bottom is the exact same segment in the triangle on the left as it is with the triangle on the right. So I'm going to put a marking here that shows that this segment here is congruent to itself. This is what we call the reflexive property. You need to make sure that you write that down. This is a very important property. Whenever you have one segment that is used twice, basically this segment in the left triangle is congruent to itself in the right triangle, which gives you another side. So these two triangles, which kind of look like a reflection, is also congruent by the side-side method. So here are two examples. If you've got all the sides marked congruent, that is the side-side-side method. Okay? All right, now look at this one here. This is an example of the side-angle side. I want you to notice that when you write it, that A is kind of sandwiched in between the two sides. It's included between the two sides. That means when you look at your pair of triangles, I've got this side with the marking of that one. I've got a second side with a congruent marking over here. But notice that the angle that's hinged between the two sides is marked congruent to the angle that's hinged between these two sides. This is an example of side, angle, and then the side. Notice that the angle has to be stuck between the two sides in order for this method to work. So if you have an angle that is hinged or kind of included between the two sides, this is a method of the side-angle side. Okay? All right, here is another example, and I'm going to pull into what we did yesterday about those different lines. Yesterday we talked about parallel lines and alternate interior angles and corresponding angles. In this example, that top segment is parallel to the bottom segment. These little arrowheads means parallel. They also are congruent to each other. So here are some things that I can add. If you look at this top line and the bottom line as two parallel lines, just like yesterday's lesson, and this is the transversal, then what we have here is a pair of alternate interior angles. They're on alternate sides. So those two alternate interior angles are congruent. So what we have here, the top side matches the bottom side, so that's a pair of sides. Then we have our alternate interior angles. That's a pair of angles that are congruent. And if I add in my reflexive property, that gives me another pair of sides. So we have side, the angle hinged in the middle, and then another side. So here is another example of the side angle side method. Okay? Now, as I come down to this other example at the bottom, this time I've got two angles that are marked equal and then another pair of angles marked equal, and this time the side is in between them. Now, if you'll remember from the previous page, we are choosing between either side, 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 angle, angle, or angle, angle, side. So when you ask yourself, which one does this one look like? You've got a pair of angles, then you have the side that's kind of in between the two angles, and then you have another pair of angles. This is a perfect example of the angle side angle. Two different pairs of angles, and the side is included or kind of sandwiched in between those. There's an example of angle side angle. Okay, just a couple more examples that I want to show you, and then we'll look at some on our worksheet. In this example, I have a triangle on the right and a triangle on the left, and they share that same side. Anytime you have something like this, you can use your reflexive property, because this segment in the left triangle is the exact same length as that segment in the right triangle, because it essentially is congruent to itself. So there's my pair of sides. I have that angle in red marked congruent to that angle. And then notice this perpendicular symbol. That is claiming that both of these are 90 degrees. So if you think about it, if that's a 90-degree angle and that's a 90-degree angle, aren't those two angles congruent? The answer would be yes. So in this example, you've got an angle, then you have another angle, and then you have the side. This would be an example of angle, angle, side. Two angles, and then you have the side. If you reflect it, two angles, and then you have the side. So there is a major difference between angle, angle, then the side, and angle, side, and then the angle. So the only difference really between these two is where that side is. If the side is not included between the two angles, you'll use angle, angle, side. If the side is included between the two angles, you'll use angle, side, angle. Okay? The last example that I have here is going to use a pair of vertical angles. I have that angle, which is vertical with that one. So here's an example of angle, angle, and then a side.